Hey, Mr. Stockton here, and today we are going to talk about minerals. So the first question we have to ask is, what is a mineral? And so I like to think of minerals as the building blocks of rocks. Okay, so without minerals, there couldn't be rocks. And so we're going to look here at a picture, and we got a large variety of minerals. And in this picture alone, we can see that they come in various shapes, various sizes, colors, textures, right? Some of them are transparent, some are going to have a metallic luster, and we'll talk more about those properties later. But what's important to note right away is that minerals come in lots of varieties. So in order to be classified as a mineral and a building block, okay, you've got to meet one of four things. And that first thing is the substance inorganic? And what that's referring to is not like organic food at the grocery store, but organic in chemistry is referring to coming from a living thing. And so minerals, they need to be inorganic, meaning not from a living thing. The second thing is, does it occur naturally? Okay, minerals should occur naturally. Okay, it shouldn't be made synthetically or by humans. It should just happen out in nature. The third thing is, does it have a solid crystal structure? And this we'll talk farther down the line about, but essentially, if we looked microscopically at the individual molecules, do they form crystals? And then finally, does the substance have consistent chemical composition? And as we're going through these minerals, I'll talk a little bit more about that, and you'll see some of these different chemicals that make them up. So in order to be a mineral, we have to have these four qualities. So even with all the different types of minerals, they basically break into two families, and the first family is going to be silicates. And so silicates contain a silica tetrahedron, and what that means is that they're essentially made of two different elements. The first element being silicon, which is atomic number 14 on the periodic table, and then that's going to combine with four oxygens, which is atomic number 8. And so these guys come together in a 4-to-1 ratio where we have 1 silicon and 4 oxygens. And you can see here that we've got the silicon being represented in the center with oxygens around it, and we've got 4 different ways we can draw this, but essentially we have this 3-dimensional tetrahedron shape that this compound is going to make. And so in order to be a silicate, you have to have this structure. So the tetrahedrons then come together to make different sorts of crystals, and so in the case of silicates we have lots of variety yet again, just like with the other minerals pictures that we showed. But we can have what are called island or isolated silicates. Okay, we can have bow tie, or where we have 2 different tetrahedrons connected. Okay, you can get double chains, sheets, rings, single chains, and frameworks. And what's really happening here is we have a variety of different ways that the oxygen elements that are surrounding that silicone can actually combine, and then they can form different chains. And what this does is it gives different properties and structure to the different types of silicates. And so here we've got 3 of the more common types of silicates. In fact, quartz here at the top is going to be the hardest common mineral, okay, on the Mohs scale, where talc is going to be the softest common mineral. It basically crumbles apart, and we use this as like a powder most of the time. And then we have plagioclase feldspar, which is one of the more common types of feldspars in our crust. Okay, so now we're going to talk about non-silicates, or the second family of minerals. So these are going to be any mineral that does not contain silicon and oxygen in those tetrahedral shapes. And so they're broken into 6 categories. The first one being carbonates. And so what carbonates are, any mineral that contains the CO3 group, okay, where we have carbon and 3 oxygens. And so here we have calcium carbonate. And so calcium carbonate is going to fit that mold with that CO3 in it. The second group we have are called halides, and so that's where we're going to take chlorine or fluorine and we're going to mix it with either sodium, potassium, or calcium. And in this example, we're looking at rock salts. We have sodium chloride. Okay, and so then the third category are sulfates, and so this group's going to have an SO4 group, so sulfur and 4 oxygens around it. And so this here's gypsum, and you can see how it's very transparent. The next one are sulfides, and so here we're going to have 1 or more element combined with sulfur. So this here's an example is pyrite, which is fool's gold. Okay, and so it gets its name because it's similarity in color to actual gold. And then we have our native elements, and so gold would be an example here, but in this picture we have an uncut diamond, and so diamond is essentially just carbon that's been there for a long time and been able to, under intense pressure, crystallize, and so carbon is the only thing that we really have there. And then we have our oxides, and this one here is hematite, and hematite has is an iron oxide, and that's what gives it its rust color. So sometimes they call it blood ore, and that's where that color comes from. So what does all this really tell us? Well, what it does is it allows us then, if we understand some of the properties of these minerals and the elements that make them up, come up with some calculations on the distribution of elements in our crust. And so if we look here at this graph, this essentially shows us that the two most common elements in our crust are silicon and oxygen. And like I said earlier, 96% of our crust is made up of silicates. Okay, and then we have our aluminum and our iron, calcium, sodium, potassium, and magnesium being the next common elements making up our crust. And so really silicates are going to be dominant, but what we do have is a large variety of minerals, both silicate and non-silicate, and the way that they come together and form and their properties are all going to be very different. And it's because of these that we're going to be able to classify them, and we'll talk later about that. So this is kind of an intro to minerals, and thanks for your time.